right. Nice and intimate crowd today. We like that. If some of you were expecting Brandon, you're in luck. I'm here instead. Brandon's got a speaking arrangement tomorrow at 10:30, I believe, in the room beside us. I'm going to be focusing on our municipal work today, and Brandon will be going through more of the federal stuff that we've been doing with NOAA lately. So without further ado, my name's Justin Proctor. I'm on the business development team here at Ecopia. And we're going to be diving into some cool innovation in geospatial data through a semi-automated extraction, and we're going to be diving into some AI stuff. So today's agenda, so we'll be going through the background and vision of Ecopia, those benefits of leveraging AI, some content development, and then a case study with the city of Jacksonville. So although this slide is an animation, it paints a good picture in terms of what we're trying to do, and that's create a digital twin. Digital twin is a huge buzzword within the GIS industry right now. It gets thrown around pretty loosely, but this is something that we really take pride in, and we really can execute. Geospatial data is the foundation of the future, especially this data that we're looking at here. All the layers seen here are digital layers, and this is what we're trying to create. And then once you have those digital representation of the Earth, a lot of cool, things become more possible. So some of the use cases that can be used with this 3D data is determining where to place solar panels on roofs, property analysis, assisting in 5G radio frequency propagation, and supporting property insurance risk assessment. So the history of Ecopia. So the idea for Ecopia was born back in 2010 at the University of Waterloo up in Canada while conducting PhD research. The focus is on extracting building footprints from aerial or extracting building footprints from aerial or satellite images while maintaining the accuracy of a GIS professional. 2015 is when we take a big step forward as a company and we begin to commercialize our data. Kind of moving on to about 2016, this is when we achieve our first large win. Ecopia mapped every building footprint across Australia for their federal government. So as you can see there, 16 million buildings across 3 million square miles, all done in about 6 months. Moving on to about 2017 time period now. As the AI technology evolved, became more efficient, we were able to grow as a company. A complete map of every building footprint in the US was generated. So 169 million buildings across 3.1 million square miles, all done in about 6 months. So as you can see there, in just over a year, we were able to 10x our results while maintaining that same time period. From here, Ecopia transitioned from man-made objects to high-accuracy land cover mapping. Because at this time, we realized we could tool the same technology for other feature classes, both natural and man-made. Then on to about 2018 now, the focus is on developing advanced land cover solution, which is used for smart cities, autonomous vehicles, and transportation engineering efforts. While doing these large-scale operations, Ecopia was able to deliver the data in a very efficient manner while maintaining the high-quality accuracy that everybody desires. And then more present-day initiatives there. This was our largest project to date. Mapping sub-Saharan Africa, so it covered 9.3 million square miles, 416 million buildings, and 11 million linear miles of roads, all done in about 8 months. So this was done more on the humanitarian side of things. So this was done in partnership with the Bill and Melinda Gates Foundation. It originally started off as a project to kind of see where they can set up polio vaccine distribution spots. And then it kind of transitioned into a COVID vaccine distribution data set. So our goal is to not create data for one customer, but to create data as a commodity that we create once, then we can tool it for many different users. And by doing this, we create an efficient business model. So these are some of the industries we like to dabble in. So you get your civil engineers, your telecommunications, your government, obviously, and then insurance as well. So this is just more of a visualization slide. So this is kind of touching on the history slide when I was going through some of those projects. So on the top left there is Australia, bottom left is United States, and on the right side you have sub-Saharan Africa. Basically what you're looking at is building footprints. So I like to point out the US one. I think it looks the coolest. It looks like there's a line drawn right down the middle of the US, but it just kind of goes to show how dense the East Coast is compared to the West Coast and Central United States. So what we're trying to do is create a fit for mapping, or a fit for purpose approach, as we like to call it. We want to maximize the utility of the data input to reach the output that is required. So we operate on two different functions. We either use our partners' imagery sets, or we can use the imagery that you guys might already subscribe to. So we work with some of the bigger imagery providers in the game, Hexagon, Vexel, but the end goal is the creation of that vector map. So we are an AI company, but we are also a geospatial services company that leverages the power of deep learning to extract from imagery sources. We recognize the importance of the human input, especially on the quality control side of things. We guarantee that all of our products exceed 95% geometric accuracy, effectively meaning that of a GIS professional. This 95% geometric accuracy gets kind of talked about quite a bit throughout this presentation. A lot of people like to throw numbers out there, but this is something that we include in our contracts and whatnot, and we really hold ourselves to this kind of high standard of that 95% geometric accuracy. So we have 3 layers of quality control to ensure that we're hitting that threshold. The data sets do not meet that threshold, it gets fixed, retrains the model until we're getting that output that we're looking for. So the old saying, fast, cheap, good, pick 2. I'm sure you guys are familiar with manual digitization, as you've probably done it at some point in your career or hired somebody to take care of it. When it comes to this approach, it's a high level of accuracy, generally speaking, but the problems begin when you start dealing with large areas, extracting more features, you start to run into those interpretation and scalability issues. And not to mention, it's very expensive over long periods of time, just paying for those man hours. Flip side of the coin, you've got automated softwares. eCognition would be a great example of this. Very difficult to use, though. They're not super user-friendly. A lot of people say it takes a PhD to operate these programs. It is a rules-based extraction, so it's able to process large areas at a low cost, but you're not able to get those updates very quickly. So where does Ecopia enter the mix? So Ecopia is creating data sets that are guaranteed to be over 95% accurate, as I touched on before. And when I say 95% accurate, our data produced is going to be higher quality than what you would have produced through a heads-up digitization approach. The data is normalized, as it is a rules-based approach, so you're always going to be getting that consistent output. We will deliver the data to you in a very fast period of time. We like to say 4 weeks from the time that we receive the imagery. So you give us the imagery, or we can source the imagery, but from the time that we get it, you will receive that data set back in 4 weeks. And municipalities struggle with updated, consistent data, and this is kind of one of the big things with AI is you're getting that consistent output every single time. So the 3 points I want to stress kind of from the first half of the presentation here are just the accuracy, scalability, and the currency of our data. So the fun stuff. So case study with the city of Jacksonville. So let's talk about what the challenge is with impervious surfaces. So as urban sprawl increases across the United States, the challenge for most cities is that their sewage infrastructure has been in place, in some cases, for over 100 years. So what's happening is we continue to build all these beautiful, all this beautiful infrastructure above ground, these communities, but we're not thinking about what's going on below ground and how we're going to deal with this excess runoff that we're now seeing from all this new concrete that we've kind of just thrown everywhere. So what we end up seeing is a significant reduction in water infiltration, but we see an increase in that water runoff. And what this has led to is roughly $9 billion in urban flooding annually in the US, and this is just from stormwater alone. There's also the ecological impacts as well. So as you can see, over 600,000 miles of rivers and streams and 13 million acres of lakes, reservoirs, and ponds are now considered impaired due to the stormwater runoff having to go somewhere and ending up in these natural bodies of water. So from here, the question is, how do we fix this problem? So the US government has acknowledged that there is a problem, and what they've done is establish regulations through the Clean Water Act, requiring municipalities and counties to have programs in place to support this, whether it's MS4 permitting or just regulations through the Clean Water Act itself. So what are the challenges that exist with these regulations? Because there's always challenges with this. The challenge is they put in place all these regulations without aligning it to a sustainable funding source. It's estimated that there's over $67.2 billion needed over the next 20 years to be able to sustain this stormwater infrastructure. There's loan programs out there, there's grants, the government is shelling out hundreds of millions of dollars right now, but those are good for today, probably tomorrow. They're not going to be good for 5, 10, 15 years down the road. This is kind of where the stormwater utility fee comes into play because that is your consistent funding source. So roughly 2,000 municipalities across the US have integrated stormwater utility fee to support these efforts, And 60% of them said that the biggest challenge was the lack of sustainable funding, and this is why they introduced a stormwater utility fee within their communities. So let's talk about what Jacksonville is doing. So Jacksonville is a coastal city, as many of you I'm sure know. Therefore, their infrastructure takes a beating due to storm events like hurricanes and tropical storms. So recently, the city has revitalized through the likes of green infrastructure, modern infrastructure, but also long-term goals of making themselves a more ecologically friendly city. They've been supporting their communities with investments to mitigate the effects of stormwater runoff, and with that, they decided to enact a stormwater utility fee. So Jacksonville started off this program by heads-up digitization, or with a heads-up digitization approach. They were just kind of doing it in-house, manually delineating all these different features. They were paying a team, and it was taking them months to kind of get this data set going and keeping it active. And then this is kind of where Ecopia enters the mix. So in 2022, Ecopia was awarded a sole source contract from the city of Jacksonville to deliver planimetric level data of impervious surfaces. So this entailed a 21-layer land cover map that was leveraged by the Public Works Department to more accurately calculate their stormwater utility fee. So part of the reason that we were awarded this sole source contract was because our price per parcel of detailed land cover data came in 84% lower than the other competitors. So let's dive into this a little bit deeper. So when we talk about data creation and supporting these stormwater utility fees, it's important to understand, how quickly our communities are evolving. So how do you go about making sure that when you update these data sets that it's consistent when you're seeing all this change? So this starts right from the beginning. You need to define the scope of impervious surfaces. What are we delineating? Is it sidewalks, building footprints, decks, swimming pools, whatever it may be? It's important to understand exactly how you want that done. And it's one thing that's very important to us is working with our clients to make sure there's not only a plan on building out what they want to see, but also building out that plan for the future to maintain this data set, because the updates in the future are honestly probably the most important part of this. But it's really important to understand 4 key points as we talk about data integration and build out. So those 4 pillars are flexibility, updates, optimization, and feedback. And then they kind of fit into these 3 stages here. So stage 1 is collecting. So we want to define the scope of work, collect the relevant data, and then extract the data in a format that enables updating year over year. Stage 2 is integrating that data. So we want to ensure that we're optimizing the resources you guys have at hand, combine it with other relevant information such as parcel data, right-of-way data, and any other existing vector data that you guys might have already created in-house. And then finally, stage 3 is just being able to maintain that data set. So we want to align with your goals and ensure that we have set update schedule, and we want to make sure this is a simple and repeatable approach for consistency and reliability purposes. So as a summary, kind of what's going on now. So the land cover data was created for over 360,000 parcels within Duval County. As I mentioned in the previous slide, Ecopia's price per parcel for land cover data was 84% lower than other vendors. And then finally, just speed of delivery. They got 360,000 parcels worth of data in 4 weeks. This is a huge game changer for them because it took them about 6 months to do this before. So now they can have these folks kind of focusing on other more important tasks instead of delineating these different features. So this is just an example of the imagery that the city of Jacksonville provided to us, or that we could kind of source ourselves. But this is kind of the end goal. This is just a few. So they had a 21-layer land cover map. This is just a few. But as you can see there, you got your roads, your buildings, forest, unpaved sports grounds, swimming pools, decks. But you can pretty much delineate any feature that you can see from an aerial image. We do satellite as well, but the aerial is definitely better. And with that, that is my presentation. Does anybody have any questions? Yeah. I've trained the AI now for 10 years. It's so smart, and it's on so many different data sets that if this is the sidewalk and there's a tree canopy over it, it understands what the 2 lines are going to meet, so we're still able to kind of keep. Yeah, sorry. Yeah. no, it works with all sides, municipalities, countries, whatever it may be. It's, yeah, there's no like minimum capture, but your question?
On the satellite imagery you guys are using, typically just standard satellite imagery, like rename names, or you guys with like multi-spectral using like
Usually,
random?
we don't. In the beginning, we used more of the satellite. We've been using more aerial as of recently. It depends where we're kind of working. A lot of the European stuff is satellite. A lot of the North American work that we do is all aerial. So if you want to get like this kind of high detailed kind of data sets, then you need that in aerials. Yeah.
So you obviously do custom projects.
Yeah.
You know, the data sets that you have, are you able to resell those? Like, do you have footprints right now and a database that you can go and purchase it right now? Are you done?
Yeah. So we have, yeah, exactly. So we have building footprints, like say off the shelf. So we've created a building or a map, I guess, of every building footprint in the United States. So that's what we would consider off the shelf. So that's something that's super easy. It's when municipalities or counties or states, whatever, want kind of that more granular detail, then that's where you kind of got to dive into these specific projects. But no matter if it's off the shelf or whatever it may be, it'll be 4 weeks or less. So, any other questions? Yeah.
Can you extract ditches?
Pardon me?
Can you extract ditches? So different topographic features?
That's a good question.
I saw you do planometrics, so I did photography with DOT, so I've done stereoscope imagery
Yeah.
with break lines on, but can you extract break lines?
Yeah. So we like to say we can extract anything that you can see from an image. We can do ditches. The natural features, it can get interesting. We're pretty good with, so we can delineate things like coniferous versus deciduous forests. But we can't, it gets harder when someone goes, hey, can you delineate this Kentucky bluegrass versus this Bermuda? It depends on the imagery as well. But yeah, we have done some stuff for the trenches for DOTs. I think Illinois, I think we did some stuff. Any other questions? Nope. All right, guys. Thanks for coming.